Okay, question came up from people that don't know better than to use their break doing mathematics. It's probably a good characteristic, unless it doesn't burn you out by the end of the day. Here are the laws of a few basic laws of exponents, okay? Without total explanation. You can do it by example. What's 2 to the third times 2 to the fourth? That means 2 times 2 times 2 multiplied by 2 times 2 times 2 times 2. Well, obviously by commutative and associative laws and everything, you can regroup that to 2 to the 7th. So what have you done? Well, you see why you add the exponents, right? Because this is how many you have here and how many you have here. So you generalize that. X to the a multiplied by x to the b has to equal x to the a plus b. Now there's subtleties that I'm not talking about yet. Yes?
Can I give you a specific example of a problem?
The what now?
Can I give you a specific example?
Yeah, let me finish this synopsis here, and then we'll answer any questions you have. Okay? Here, 2 to the third to the fourth means what? Well, 2 to the third times 2 to the third times 2 to the third times 2 to the third, right? And I went to all the trouble of writing that stupid thing out. Okay, there's 2 to the third, there's 2 to the third, there's 2 to the third, there's 2 to the third. 3 2s, 4 sets. That makes 3 times 4 2s, which is 12 2s, 2 to the 12th. 2 to the 3 times 4. So x to the a raised to the b had better be x to the a times b. And you can always figure these things out, and I did, through high school, even into college. If I wanted to be sure I had the laws of exponents right, I just think of simple powers of 2, not too simple, okay? Using, basically 2 with third and fourth powers, and I could do this. Also, negative exponents. This is going to be important. So you got to know this. It's going to be important for something we'll probably do later today. You know that x to the negative a times x to the a should be x to the a plus negative a, right? Which is x to the 0, which is 1, right?
Yep.
Okay? Well, that turns out that x to the negative a, well, x to the negative a times x to the a equals 1, right? Means x to the negative a is 1 divided by x to the a, right? Those are things you really have to understand, lock in, and never forget. Because later on when you do logarithms, you'll be like my pre-calculus class was when they had to learn the laws of logarithms. They didn't understand the laws of exponents, though I'd been nagging them about it from the first day. And that was a good class. So they never did really understand the laws of logarithms and screwed it up in the final. Okay? Most of them. Okay? So we're not going to talk about logarithms. We might well at some point, but not at this point. We don't need it right now. Just understand that the logarithm is an inverse of an exponential, if you know what inverse functions are.
Yeah.
And we'll actually be playing around with that a little bit, but not this week. Okay?